Alright, so we're going to do notes on trig, or trigonometry. And we use trig to find a missing side when you're given information about one side and an angle, which is different than what we were doing with the Pythagorean theorem, because on that one you get two sides and you're looking for the third. With trig, again, we're going to be given one side and an angle, and we need to find the other one. So there are three trig ratios that you have to know about. The first one is the sine ratio, and then you have cosine, and then you have tangent. So let's talk about the difference between them. So in an earlier video you watched on how to identify the opposite sides, the adjacent sides, and the hypotenuse of a right triangle. So if you're looking for sine, which they abbreviated as SIN, that means you have information, or you're looking for the opposite and the hypotenuse, meaning there would be nothing on the adjacent side. Okay, so it's a ratio, opposite divided by hypotenuse. Your cosine is the adjacent divided by the hypotenuse, and the tangent is the opposite divided by the adjacent. So as long as you can OAH your right triangle, so you know the sides, you should be able to figure out which trig ratio you need to use for each problem. Okay, and so to give you some kind of visuals, here we have our reference angles. So if we want to have sine, which is the opposite and over the hypotenuse, if our reference angle is 53, that means we'll have information on the opposite side of the triangle and the hypotenuse. In the cosine, you're going to have something on the adjacent and the hypotenuse side, based off your reference angle. And then for tangent, you'll have the opposite over the adjacent. So again, you'll have information on the opposite side of your triangle and the adjacent side. So remember, hypotenuse is always across from the right angle. The opposite side is the side directly across from your reference angle, and the adjacent side is the one that is the other side that makes up your reference angle that's not the hypotenuse. Okay? So sometimes that's a lot, but we have a saying that will help you remember this. So remember this saying, and it's going to sound funny when I say it. So-ca-toa. And so if you learn how to spell this, S-O-H-C-A-H-T-O-A, so-ca-toa. Kind of like suck a toe, but not. Okay, so so-ca-toa stands for it'll be sine if you have the opposite and the hypotenuse. It will be cosine if you have the adjacent and the hypotenuse. And it's tangent if you have the opposite and the adjacent. So if you remember so-ca-toa, you will be able to remember which one you're supposed to use. Okay? So some important info. In order to solve these problems, you're going to have to use the Desmos calculator. Do not try to use your phone calculator. Use the Desmos calculator, because you're going to have to make sure the calculator is in degree mode. If you do not put the calculator in degree mode, you're going to get the wrong answer. So take a second and pull up Desmos in the split screen so you can see how to do this. So right here I have up a split screen, and I'm going to show you how to turn the Desmos calculator into degree mode. So once you're in the calculator, hit this little wrench up here, which is your graph settings. And down at the bottom, you see how the radians is in green. So I want to select degrees so that the calculator is in degree mode, and that one's going to be in green. And then so once you hit that, now your calculator is in degree mode. You will have to do this every time you open up Desmos in order to make sure you get the right answers. All right, so now we're going to go through 5 practice problems. You can go along with me. All right, so here is example 1. We want to find x, so that means we want to find the length of side x. So in example 1, we need to find x. So the first thing I want you to do is, from your reference angle, I want you to make sure you go label your hypotenuse. Then we're going to label our opposite, which is opposite from the reference angle, and then our adjacent. And then we're going to determine which one don't we have information on. We don't have anything on the opposite, so we're going to ignore it. So I kind of cross it out. And so if I stay with my SOHCAHTOA, only thing I have left is the AH, which is here, which tells me I'm going to use cosine. So in order to set this up, you do cosine of the angle, which is 34 degrees, is equal to, now cosine is adjacent over hypotenuse in that order. So on the adjacent side you have x, and over on the hypotenuse you have 19. Okay, so that's how you're going to set this up. And then we're going to go ahead and make this a proportion. So we've been doing cross multiplying in the previous unit, so let's go from there. So once we do that, we cross multiply. So now I'm going to have 19 times the cosine of 34 degrees is equal to 1 times x, which is just x. Okay? So now we're going to simplify. We're actually going to figure out what the cosine of 34 is. And so I want you to remember, like, cosine of 34 is just a number. So we can figure out what it is. So go over to your Desmos. And once you're here, you can do this a couple ways. So you can look under functions, and then trig is the one that comes up. So now you have your sine, cosine, and tangent. And so this one I'm going to pick cosine of 34. And there we get this decimal of 0.829. And we can just use that. So now I'm going to put this in as 19 times, now the cosine of 34 is really just the decimal 0.829. So I'm going to do times 0.829 is equal to x. And now we just need to multiply 19 times the 0.829. And for this one, we get 15, and we can round to the nearest tenth. 15.8 is equal to x. So that means the length of this adjacent side is 15.8 units long. All right, so example 2. I have one side given, I'm looking for another side, and I have an angle, so that's why I know I'm going to use trig. So I'm going to go ahead and label. I'm going to start with the hypotenuse, which is here, and then if 64 degrees is my reference angle, x is my opposite, and then this side is my adjacent. So I have no information given on the adjacent, so I'm going to cross that out. So now I have the opposite and the hypotenuse, the O and the H, so I know I'm going to use sine. So to set this up, I know the sine of the angle, which is 64 degrees, is equal to the opposite over the hypotenuse, which is 20. And then we're going to make a proportion and put it over 1. And then we're just going to cross multiply. All right, so we cross multiply to get this equation. Now we just need to figure out what is the value of sine of 64. And so you can, again, hit the functions button in the Desmos, trig comes up, hit sine, or you can just type in sin, and then in parentheses, put the 64. And now we know the sine of 64 is 0.899 rounded, so we'll go with that. So we get 20 times 0.899 equals x. And then we're just going to multiply these two things together. All right, so when we do that, we get 17.98. And rounding that to the nearest tenth will actually give us 18.0 equals x. So round it. That means the opposite side on this triangle is 18.0. All right, so let's try the third one. So let's go to example 3. Hang in there, we're almost through. So in this one, let's label our hypotenuse, because we always know that's across from the right angle. Then from our 28 degree angle, here's the opposite, and here's the adjacent. So now I'm going to cross out what I don't have. I don't have anything on the opposite side. So now I have the A and the H left, so I know I'm going to use cosine. So now I'm going to set this up. Cosine of 28 degrees is equal to your adjacent over your hypotenuse. All right, so go ahead and pause the video and see if you can finish this and come up with an answer. All right, so going through doing this work, you should have ended up with rounded about 17.7. Okay, so let's try example 4. Again, we're going to start off by writing the SOHCAHTOA, so that's going to help. All right, and then we're going to label our triangle. So here's my right angle. So here's my hypotenuse. Then from the 73-degree angle, here's my opposite. And down here with the X is my adjacent. Cross off what I don't need. I don't need the hypotenuse. So now I'm left with the O and an A. So that means I'm going to be doing tangent. So now set it up. Tangent of 73 degrees is equal to the, remember tangent is opposite, which is 14, over the adjacent, which is X. And that's okay. It's a little different with the X in the denominator, but it's okay. You're still going to cross multiply and solve. All right, so then we're going to set this one up. We're going to cross multiply. So now it's X times the tangent, 73 degrees is equal to 14. And now we're just going to figure out what the tangent of 73 degrees is by placing it into. And so we get the tangent of 73 degrees is rounded about 3.271. It's equal to 14. So this is just a one-step equation, so I don't want you to panic. The X is by its times of 3.271. You could also rewrite it to look like this. That makes you feel better. So we need to get X by itself. So all we're going to do is divide by 3.271. And so now we're going to do that in a calculator and figure out what X is. And so round it to the nearest tenth, we can get 4.3. So that means this adjacent side is 4.3 units long. All right, let's try the last example. Again, we're going to start by writing down our SOHCAHTOA, because that's, and once we've written that down, we're going to label our triangle. So always the hypotenuse, then come to the opposite, and then label the adjacent. Which one do we not have any information on? The adjacent. So let's cross it out. So now we're dealing with the O and the H, which is sine. So let's set up our problem. Sine of 52 degrees, degree sign in here, is equal to the opposite over the hypotenuse. Again, we're going to set it up, so make our proportion, and then we're going to cross multiply. And then once we get that, we're just going to figure out the value of sine of 52 using Desmos. So we get that is to be 0.788. If it makes you feel better, rewrite it. And now we're trying to get X by itself, so it's just a one-step equation. Divide. And you end up rounded to the nearest 10th. X is equal to 15.2. So that means the hypotenuse here is 15.2. All right, and that's all your notes.